When we look at the different ways to compare fractions, we have visuals we can use, we have some calculations we can use, but I'm going to look at 2/3 and 2/5. And when you first started comparing fractions, you probably use things like fraction bars. If we colored in 2 out of 3 here and 2 out of 5 here, they are the same size, so we can see that this one is bigger. So which fraction is greater? That would be 2/3. Number lines are another visual we can use. From 0 to 1, there's 3 equal pieces. So this would be 1/3, 2/3, and 3/3 is the same as my 1 whole. 0 to 1, we have 5 equal pieces. So here's my 1/5, 2/5, 5/5 would be up here with my 1 whole. So you can tell me which fraction is closer to 0. We can see 2/5 is physically closer to 0. Which fraction is closer to 1? 2/3 is physically closer to 1. So if you have 2 fractions and one of them is clearly closer to 1, one's closer to 0, you can tell which is bigger that way. Okay, another way to compare fractions is using 1/2 as the benchmark. So thinking, is 2/3 greater or less than 1/2? So I know half of 3 would be 1.5, and 2 is more than that. So I know that 2/3 is greater. I can also think about, for example, cutting this in half up here and seeing that where it's split, the 2 goes beyond that in the 2/3. So 2/3 is greater. And then if I look at 2/5, is 2/5 greater or less than 1/2? Well, it takes up less space on the 1/2 side. It doesn't fill it up totally. So 2/5 would be less than 1/2. So 2/3 is greater than 2/5. And some of the more common ways we're going to use would be common numerators and denominators. So if your numerators are the same, and that's what we have here, the top numbers are the same, that's the same amount, but different sizes. So for example, 2/3, we can say that that is 2 pieces of size 1/3, whereas 2/5 is 2 pieces of size 1/5. So if I were to cut up a chocolate bar, and I had 2 chocolate bars, and I cut one up into pieces of size 1/3, and then I cut one up into pieces of size 1/5, well, these 1/3 pieces are going to be bigger. We can see that up here in the visual. Okay, and then this is the most common way when you have fractions that don't meet any of the other requirements. They're not close to 1, one's not bigger than 1/2 or bigger than 1. You can just get a common denominator. So when you get a common denominator, you're finding LCM, just what we did in chapter 1 here. So the LCM in this case of 3 and 5 would be 15. And then we're finding equivalent fractions. So to get from 3 to 15, 3 times 5, and then I have to do 2 times 5. Whatever I do down here, I'm going to do that up here as well. So I get 10 15ths. To get from 5 to 15, I do 5 times 3. So then I multiply the top by 3 as well to get 6. 10 15ths is more than 6 15ths. So 2/3 is greater than 2/5. Now, if you don't remember your symbols, we don't want to rely on the alligator teeth and those rules, because eventually we're going to get into some algebra and then a whole chapter on inequalities with algebra, and so you may not always know what's on either side of the symbol. It may be a variable or an unknown, so you have to know what those symbols mean. So one thing you can do is use your left hand, hold up your left hand, and make that less than symbol with your left hand. Left hand and less than both start with L, so that's one way to remember.